Here today we have the Boonton 2520 RF Calibrator. I showed this in the mailbag previously a while ago now, and I did identify that it is at least working, but it had some issues. So I'm going to just repower it now and just verify it does still work. The issues it had were subtle. 230 volts in. I've already changed the voltage selection switch on the back. When I did the sister model to this, I think it's 2510 I think it was, which is very similar, looks exactly the same, so it's got a different socket on the front. And it's a DC calibrator and RF calibrator. They're both two different things. This is for calibrating with the RF sensor heads, and the other unit is for calibrating without the RF sensor heads. So the other unit you use to calibrate the actual RF power meter, and this one here you'd use to check the sensor head is correct and the whole system is correct. But they're actually very similar units, which is why they look identical. We've got the same display set up. It's even got the same circuit board inside it. So that was quite surprising. Anyway, so this powers up, and it's got an orange display which is not very bright on screen. I'll try and get it. You can kind of see it's there, yeah? You can kind of see it's there. But for me, I can see that quite easily. The camera is not quite as responsive on it. It looks worse on camera than it is for me. So now the other unit I worked on before, the display was so bad even I couldn't read it. And I actually did placing that display with another one, because it is just a standard 2x40 display. This has got an EL backlight on it, electroluminescent backlight. I had to obviously disable all that on the other unit and just replace the display with a standard LCD. So that video is on my list. If you haven't seen it yet, you can go check that out. After this video, of course. It is working. I've tested it. I've confirmed the outputs are looking really good. I put this onto my spectrum analyzer. The levels all look good. I know the calibrator is actually working well. This thing goes from minus 70 dBm up to plus 20 dBm, which you can't see on camera, I'm sure. Maybe now you can. Alright, so plus 20 there. Down to minus 70 there. That's the range. And this has got a fixed frequency. It's a 30 megahertz output. But yeah, it's a really simple unit. If you want to change it to say 69 dB, whatever, you can do that too if you want to. You can do in those steps. And you can turn the output on and off. Output on, output off. It does actually work. Well, you're probably going, why is it that I'm working on this thing now than in the video? If it works, what is there to fix? Well, there's a few things to fix. I'll put it apart and I'll show you. The first thing is on the back here, the transformer casing, metal casing. It's got a big dent in it. You might be able to see it better from the side. See that big dent? Now, I don't know if it's actually touching the transformer or not. It could be. So I want to fix that. So there's a bit of mechanical work required there. There's some capacitors, and you can see this one's all bulgy. See, those are nice and flat. This one's bulging. See that bulge there? So the caps need replacing. So the circuit board is the same as in the other unit. Well, I think it's a slightly later revision. It's almost identical. When I first opened this thing up, I thought that is exactly the same board. In fact, if you look up here, 25102, 2510-2. So I think it's revision number 2 of the 2510 board. Now I don't remember what the revision was on the 2510 version I did before. Might have to go back and look at that. But it's very slightly different over here. This power supply section is very slightly different. But the rest of it looks identical, the way it's set up and everything. So you've got some dip switches up the front here. Just make a note of those in case you accidentally hit them. The only one which is open is switch number 7. The others are closed. The other unit I looked at had a connector on here. That had a plug in there as well, the 2510. So it's a slightly different configuration. I don't know exactly why it is, but it is. We need to pull this board out, recap it. Whilst the board is out, then I can get this transformer out, or at least dismantle it, try and get that back cover off and take the dent back out of that whilst the board is out. So that's the plan. So to get this out, you have to remove the heatsink which is attached to the side chassis, which is mounted onto the regulator ICs. We'll get this panel off as well. There's the screws. So we need to undo those so we can get the heatsink off. Now when I did the other unit, the 2510, there was no heatsink compound behind here. I actually added heatsink compound just to help the regulators run a little bit cooler. I mean, in fact, there was nothing there from factory. It means it's probably fine. I mean, it's been like this for how many decades now? But there's no harm in helping it a little bit. So that's those out. We've got to get the board out. So a lot of these are obvious where they go. You can't get it wrong. Famous last words, isn't it? There's two here. The orange and black is towards the front. And then you've got the brown, and it also goes that way, so wires come out the right hand side. Okay, so the orange and black is the front one, the brown and white is the rear one. Actually, they might both be 5 volt outputs, I'm not quite sure. Could be the same thing, but best not risk it, keep them the same way. And you've got this plug that goes to J5, unplug that one. You've got one here goes to J9, wires go to the left hand side. Then we've got the GPIB connector. That one there. Now we get to all the screws, get the thing out. The magnet just helps the screw to stick to the screwdriver. So when you've got ones which are in awkward places, then they come out with it. Just helpful. Just makes the job easier to do. If I'm trying to get into with tweezers. Could also make it easier to put them back in again as well. Obviously not all screws are magnetic, so you know that could be a hindrance. Depends on what screws there are. Pulled out. And the transformer is going to be awkward because I've got to get it from both sides. We'll do the circuit board first, then we'll worry about the transformer. Now the board's out, I'm going to recap the entire thing. Every capacitor is going to get replaced. Now the tricky thing is to make sure you put the capacitors in the right round. Even I get that wrong, like I did one yesterday. Actually I'm going to slide that off, I better reuse it. And I accidentally put some big caps in backwards on a live stream, so that was great. They got a bit warm, didn't blow up. Yeah, you know, these ones here. This power supply is knackered anyway. I was hoping to fix it, but yeah, it's a shame. So 1, 2, 3, 6, 9 caps. I will need this. Unfortunately it's a little bit noisy, but that's what we need. What values do we need? 10 microfarad 25 volt, 10 microfarad 25 volt, 10 25 volt. So these are bigger. So these three are the same, and the ones up here, but the regulators are it's like 100 microfarad 25 volt at least for this one. I might have to look at these ones as I take them out. We'll get the small ones out anyway. 10 microfarads, 25 volts. Let's get some of these. Problem with my eyesight getting worse is making this sort of stuff harder to do. That's a 35, that's good. It doesn't really matter usually, but I just like to keep them all exactly the same if I can. If I'm replacing caps, I try and keep them as a set so they're all exactly the same caps for the whole lot. Sometimes it matters, usually it doesn't. But I like to try and play it safe. So just over here, it's an AD581JH from 1995. These other chips are 95 as well, so it gives you an idea. So this thing is basically 30 years old. So I'll start taking these caps out. The left side is negative. So I'll put fresh solder on first. In fact, I'll just do fresh solder on all the caps first, then I'll come back and suck them all out. Fresh solder just makes them easy to get out. That's one. Now I'm going to do the sensible thing here and put them in as I take them out, because otherwise I could lose track of where I'm at and accidentally put one in backwards, and that's always a bad thing. Don't ask me how I know. It could be anything. This tool is one of the best things you can get if you do electronics repair stuff. It just makes refurbishing things so much easier. It just makes it easy. Solder those back in. I'm not going to use flux. I don't tend to use flux unless I actually need to. I'll just try soldering and assess how it's going and base it from that. And I should really turn the extractor on, which is why I'll put the hood here. That's a third of the way there. You get the idea, I won't record the rest. The capping's not exactly exciting. The exciting bit is when you power it back up again and find out you put the caps in backwards. Yeah. So now we're soldering these big caps. So we had two 2200 35 volt caps, which these two ones which were not bulging, and then we've also got a 4700 microfarad 16 volt was the one which is bulging, so that's the one which I've also done. So that's all the caps done. So once I've done that, I'll clean the board up. I've got to try and do the transformer and see if I can get that to not be dented anymore. It's not something I had to do before, so it's a bit of a new experience for me as well. I've never had to take a transformer apart like that, so we'll see. It could be interesting. I could completely screw it up. It could be easy. I don't know. Never done it. We'll find out shortly. Let's actually check these caps that I've pulled out and see what kind of readings and stuff we get off them. So this one here is the 2200 35 volt, one of them, 237. So it's fine. ESR 60 milliohms. So that's actually still a good cap. But I like to replace these things anyway. This one here, which is the same cap. This one's 2.4 at 51 milliohms. So that's also still good. I'm just sort of suspicious about this. See this stuff here? And it's also looking slightly bulgy on the bottom. It could be starting to go. This one here is bulging on the top. That's a 4700. What do we get? It's really slightly low, and the ESR is only 46 milliohms. Also still measures good, but it obviously isn't because it's bulging. So let's do this one, which is a 100 microfarad 25 volt, measuring okay, 1.2 ohms. That seems normal. Same again, really slightly low, and the resistance is still about the same as well, but that's basically okay. I mean, none of these caps seemed horrendous. I mean, the actual unit worked fine. There was no signs of issues with the power supplies, but it's still just a good thing to do. So this is a 10 microfarads measuring 11, so it's 10% up, 8.8 ohms, probably okay, maybe a little bit on the high side. This one's 12, so this one's definitely worse. This one's on the way out, and this one's 5. Okay, so this one's better. So the 8 is also bad, so that's two of those small caps are definitely going. But that's why I measure at 100 Hz, because it actually makes things more obvious. So yeah, I mean, recapping was needed, but this is why I just do this. I mean, I could have just replaced the obviously bad cap and moved on with my day, but the small caps wouldn't have been so obvious, so, you know. But this is what I do. I mean, I recap because it's an old piece of gear, it's 30 years old. I mean, the caps could even be okay this week and not okay in a month's time. You know, they could suddenly start leaking and that sort of stuff. The really well-made caps from many years ago, they can still be perfectly good for several more years, but you don't know, it's a gamble. I'm very much a case of, if it's not a big deal, replace them all, have done with it, and at least now you've got caps which are probably fine. I mean, they may not last 30 years like the originals did, but you probably get 15 years out of them, and that's probably long enough. That's all the RF stuff, so I'm just trying to assess how much there is to take off the rear panel here. I'm hoping I can just take the rear panel off, and then I can strip it down and then straighten the back panel as well, because the back panel is also very bent, as it turns out. You can see it there now. I've got these other panels off. You can see how bent that is. This one is straightening too. Maybe that way you can see it too. It's dented in. I like to straighten the whole lot out, not just the transformer. Let's take it apart and see how far we can get with it. See what we come across. Thankfully they use the same screws for everything, so it's really easy to not mix them up. And I think the one I'm really worried about is this bit. I'm not quite sure if that goes in, which I might have to then desolder. I'm not quite sure. Yep. Okay, that control out is also plugged in. That's good. So I've got one wire I got unplugged, which is coming through this little snatch thing there. Unplug that, and then we can work on the rear panel by itself. That's great. I love this design. Love designs like this. Yes, I do when I can get the things apart. Come on. There we go. Lovely. This makes things easier. So now all I've got to do is unmount the transformer, which is something I need to do anyway. Mind you, I've got wires going in there. I've got to be careful with that part. I think I need to take this cover off here too and have a look and see what's inside here. Those are wired directly on, so I have to be careful with this. So this is going to be a little bit trickier, but not too bad. Just got to be careful. So I need a nut driver to get under these. So that's all the nuts off and the washers are off. So now, in theory, I should be able to get these bolts out from this side. They may just unscrew out. Now when I do this, I've got to be careful about the wires on the transformer, because obviously they're a bit short on the input side, on the primary side, and I've got to be careful not to like drop the transformer and have it yank on the wires or anything like that. And it should be straightforward. I mean, I think I've just got to basically get these bolts out, take this cover off and straighten it out, and whilst it's out then I've got to try and do the back panel, which could be a little noisy, but the back panel is aluminium, so it should be pretty easy to straighten that back out. That shouldn't be hard at all. This tougher to deal with. Right, so I've got those bolts out now. Let's lift this out. And like I said, I've got those. Oh, I'll take this cover back off again. That was silly putting that back on, I think. Gives us the freedom to move things around a bit more. Okay, there we go. I've got to get this cover off. There we go. That was easy. And so it could have been rubbing on this transformer just here. It doesn't look damaged. I think it wasn't touching, but I still want to straighten it out. And then I've also got to do the back panel, which is aluminium, so it should be easy to straighten back up. So I've got these hammers here. I'm just going to use this one to try and get it initially straightened a little bit. Can be a bit awkward trying to do these sorts of things sometimes. That's already popped out a little bit. Alright, and in fact it wasn't actually touching transformer. This is more of a cosmetic thing than anything else. So I'm going to try and get that to be kind of right. I mean, unfortunately it's not. I'm trying to hammer it a bit, which is bent, which isn't helping. Obviously I've got it flatter, but I need to kind of pull it out. So that's going to be a little bit awkward to do. Yeah, I'll probably need to support it on this edge here, so I can pop that out to where it's supposed to be. I have to figure out how I'm going to do that. There's always ways. Sometimes it's awkward. Okay, I found a way, and it's awkward and it's off camera, so I'm not going to record it. And it's noisy anyway. So yeah, it's beaten out. It's basically the right shape now. It's good enough. It's certainly better than being dented inwards. It's not perfect, but to be honest, it's good enough. It's not in anymore. Now to do the panel, which one should be a little bit straightforward. I should be able to literally stick on this like this and just use the soft hammer and pop that back out. It should not take much at all. It's getting there. It's not there yet, but it's getting there. So that's all panel beat now. That's basically flat. It's flat enough. It's certainly better than it was, so we can put it all back together again now. So I'm going to use some of this thread lock on these bolts as well, just like the original did. The factory had some thread lock on there of some kind, so I'm going to do the same as well, just to make sure that they don't vibrate loose. There's a transformer, and transformers do vibrate very slightly. I'm just going to put that on there and make sure that these don't come loose by themselves, because you don't really want that happening. Last thing you want is one of these things floating around inside the unit. Just notice this fuse holder is loose as well, so we can tighten that up while we're in there. Hopefully it's not like a cracked nut or something, that can happen. Or stripped threads. No, it is tightening, so let's get in there with some pliers. Now this is a bit awkward to get into, especially I'm trying to do a video about it as well. There you go. Nipped up, that'll do. Won't take much. So that's the rear panel refitted. Now we're going to put the circuit board back in again. And I'm also going to put some thermal compound on this. On these regulators, just to help them to dissipate heat into the chassis. Like I said before, it didn't have them on there originally. It's probably fine, but why not do it? It's probably a good idea. So I've just placed the board back in again, made sure all the wires are out, at least I think they all are. That's always a pain when you put something together and find there's a wire trapped underneath. So the first thing I normally do actually is actually plug all the wires in, but in this case some of them will be in the way, so I'm not going to do that. I'll just sort of visually go around and make sure that they look like they're okay. Then you've got the issue with potentially got the regulators being stressed, trying to be pulled towards the chassis. So I'm going to do is mount that on first and then do the screws on the PCB. That way it should have no stress being applied to the regulators, because they can crack. The actual legs can break off, or the circuit board traces can break, the actual pads can break and that sort of stuff. I've seen that before in regulators because of the thermal effects as well, because it's thermally cycled. I've seen that before where the trackers actually, like the solder pads are broken by the regulator legs and that sort of stuff, and they've been pulled, and I've gone to resolder it and things actually shifted because it's been soldered and then applied, and then that meant that it was all being stressed, and that's what made it crack. So, and of course those are countersunk screws that can only really go one place anyway, and then that guides the rest of it to where it's going to be. Now we should put this back in again. Now, where's my magnet gone? Because this makes this job a lot easier. Stick that on there like that. I'm just going to put them in, not tighten them up yet. Go around afterwards and tighten them up. You don't tighten them straight away, otherwise what can happen is you'll get ones which are then not lined up properly and you end up going a bit crooked and things like that. And the board is going to be mostly aligned because of the fact we did the regulators first, but you can still get some slight offsets. There is still a bit of play and things, it will still move slightly. Anyway, I'll come back once I'm done, you get the idea. So I'm just plugging all these plugs back in again now. These ones are the ones you've got to be careful of. These are very easy to bend the pins on if you're not careful. Now, which one was which? I think that one, or that one. Which was the one which is closer? Oh. Yes, that was there. The orange one was here. So that's in. Dip switches are still in the same place. That's in, that's in, that's all in, that's on, that's all done. Right, let's power it up and see if it still works, eh? Or have I destroyed it? Well, it's booted up. There you go. Change the levels, that still works. So it's probably good. Do you think I should actually track the output? And I should check the output, shouldn't I? Just to prove it does still work. Let's do that. I'm going to set this up on my spectrum analyzer, which is up there, and I'll change the camera view to show you that. And the idea then is that I can demonstrate the RF output accuracy on the spectrum analyzer. So here's the spectrum analyzer. This is already preset to show the thing on the centre of the screen there. I'll turn the output on. This is set at minus 70 dBm. And it's basically right down in the noise right there. You can just see it peaking up there where the marker is. Just see it. If I set the spectrum analyzer up differently, you could probably see it a lot easier, but this is good enough for now. Let's go to minus 60 dBm. There we go. And it's sitting around the minus 60 dBm point. Minus 50, and so on. 40, 30, 20, minus 10, 0 dBm, plus 10 dBm, plus 2 dBm. So as you can see, that's all looking fine. Now something I haven't figured out how to do on here, even with the markers, is to see what the actual level readout is. I'm sure I can do it, I just haven't figured out how to do it yet. I don't know, maybe I should read the manual or something. Anyway, so that's 0 dBm there, and I go down by 1 dB at a time. See it's stepping quite nicely. Back down to minus 10, that's fine. I even do decimals, so that's currently minus 10. And I can do minus 10.2, 0.3, 0.4, and so on, and bring it down. That's now minus 11. So that's working all fine. All the attenuated stuff is working good, so I'm happy with that. When I did that just then, it crashed and rebooted itself. Was it a little firmware glitch just then? Did I just find a firmware bug? Let us repeat what I just did. I went from minus 10 down to minus 11 in 0.1 steps, down to minus 10, and then down again, got to minus 50 and crashed. That's awesome. So I don't think we're quite finished yet. This thing's rebooting itself. So we know the output's working okay, so we can get rid of this part. But when it's just sitting here, it's just done it again now. It's rebooted again now. It's stuck. Something's going on. There's a problem still. Now it could be something I've done. Could be I've made a mistake or disturbed something. I'll get the thermal camera out and we'll see if something's getting hot. I'll turn the output on. That way I can see what's dropped out or not. Let's Get this on the camera, see if anything's getting warm. Oh, it's rebooted. Let's have a look, see if anything's getting hot. There is definitely something hot over there. $87 degrees. The bridge rectifier is really hot. That's 85 degrees. So it could be something overloading the bridge. What's overloading the bridge? Oh, there's a chip down there which is getting really hot. 43 degrees. There's two of them. They're not too bad actually. 43. Although they're warm, they're not that bad. Yeah, the bridge is definitely getting very hot. That makes me suspicious. So unplug this and unplug that. And see if that bridge comes down in temperature. Seeing 82. That is getting cooler. 77, still coming down. Interesting. So I'm basically stripping this apart, trying to get this panel out because I want to see what's inside this section. In case there's capacitors or something in there which is giving trouble. Thermally I can't see anything else anywhere wrong. Taking the whole front panel apart, which isn't actually that hard, it just all falls apart. It's just like lots of little pieces. Now it's off, actually it'd be a good time to clean it. But I'm going to take all these screws out of this panel here. I have to get this one out, which is why I take the panel apart. I also lifted it. Nothing on the other side. I've got to take all these out as well. Potentially, I think we're looking at the bottom of the board on this side. So, actually what I might do is unplug it and work it on the bench. That'd be a bit more sensible, wouldn't it? Let's do that. Get this out of the way. Unplug this. Work on it like that. It didn't fall over then. So there you go, we've got the bottom cover off. That's what's on the inside, on this side at least. That's all we can see from here. Nothing to see. Let's take the screws out the other side and see what's on the other side of the board. So that's the top cover off. So it'd be 30 megahertz oscillator there of some kind. Then we have some amplifier buffer stages, may even be a POL system, I'm not quite sure. Don't think so though. Looks like it's too discrete. And then we have some amplifier stages here, and these are probably attenuator sections in some way. I have to wonder how it's doing the attenuation because it does 0.1 dB steps, 1 dB steps and 10 dB steps. So I'm actually wondering how is it doing that. Right, it's 3 relays here. Could be careful not to touch anything. But there's one electrolytic cap in here. So yes, we did need to come in here because that cap will need replacing. But there's no tantalums that I can see. Nothing standing out as tantalum. There's ceramics. We'll replace this cap. Could that be the problem? Unlikely. Yeah, it's unlikely that cap is the problem, but it's there. It's going to need replacing because to replace the other ones. At least then the whole thing is done. Don't have to worry about it anymore. Once I've replaced that cap, plug it back in again, repower it and see if anything is looking obviously bad here. Maybe something's not happy in this board. But then it does seem to be working, so I don't know. Right, so I've just taken this capacitor out. Negative goes that way. Let's test it. 7.8 ohms, 11 microfarad. It's supposed to be a 10 at 25 volt. 7.8, it's sounding a little bit on the high side. Let's get a new one. And we'll test what the new one is. 6. So it's definitely lower. It's got a lower capacitance, but usually because they've been sitting around for a while, they need a bit of reforming to happen. It's probably come back a little bit better once it's been used slightly. It's definitely better than one that was in it, which is the main thing. It's got a lower ESR, so we'll put that one in. So this very end relay here has actually got a lot of flux around there. I'm actually thinking I'm going to clean that off. It's almost like someone's resoldered that at some point. Maybe they had a dodgy connection or they replaced it or something. I'm going to clean that flux off because I don't think it should be there. Right, let's see what happens. Turn this on. That lit up. That's actually running. Interesting. Let's plug that cable in. Okay, well let's look for hot spots. This is the whole point of this. I've got the camera out here now. And it's going to check for anything which is looking like it's bad on this circuitry here before I put it back together. Because it's all reflective metal, it's all shiny, which makes it a bit harder to find things which are hot because it's still reflecting off the surfaces in the room. The bridge is up to 39, 40 degrees already so far. Yeah, it's already up to 41. It's still climbing. This board looks fine, there's nothing getting hot in here. Yeah, nothing on the front panel either, that's all looking fine. That bridge is just getting hot for some reason. I'm wondering if the bridge is faulty. Yeah, that section's looking absolutely fine, I'm happy to put that back together. That's the only thing I'm seeing is the bridge and that resistor. And there's 2 chips at the back there which don't matter. Right, I've taken the board back out again because I want to test this bridge to see what's going on there. Try and pop it up so you guys can see. So those 2 there are the AC, those are the DC. So I should be able to measure from one side, whichever side's the negative side or positive, I don't know. That's charge up capacitor and it's reverse biased. And that should be the same, it is. This should be the same, should also be reverse biased. Yep. And so should that one. Yep, that's looking promising. So it means this will be positive terminal, this will be negative terminal. Diode junction, diode junction, diode junction, and diode junction. It looks fine, which only creates more questions because it appeared to be that it wasn't happy about something. Well, that bridge tested as okay, but I'm suspicious about the temperature being so hot on it. I mean, they can get hot, they can, the speed of the way they operate. Sometimes you do get a voltage drop through the bridges and it is quite normal to get some heat, but it seems excessive, and especially with the actual voltage regulator not getting that hot, and it's only running the 5-volt regulator, and the 5-volt supply is one which is cutting off and rebooting. So I'm leaning towards a bridge being the fault. So I've got another bridge just here. It's probably fine. I mean, it's only a 1 amp, maybe 1.5 amp regulator, so I'm pretty sure this will do it just fine. It's an international rectifier version. It's rated 6 amps, so I guess that's what the 606 means at the end of it, probably 6 for 6 amps. We'll pop this one out, pop the new one in, put it back together, and see if the problem goes away. I mean, we don't know for sure that's what it is, but it's a pretty high likelihood the bridges was at fault. I've seen bridges go quite often, that does happen, but it's usually the small round ones, because they only rated like 1 or 2 amps themselves. I think maybe 3 amps, can't remember. But they're only really small round ones. Those ones fail a lot. I've had to replace a lot of those. This type usually are pretty good, but something's not right, so let's just pop it out. So that's replaced now, all soldered up, looks nice. I stood it off the board a little bit instead. Last time it was flat on the board, this time I've raised it up. So it means now, if you need to from the top side, you can actually probe the bridge from the top side of the board. The other thing, it also means that if it is getting hot, it's not putting heat straight into the board, and it helps to make sure it doesn't damage the board. But the fact there's no like dark staining on the board already means there's a good chance that this wasn't getting hot originally. So yeah, so I've replaced this as I've shown, and the power draw from the main supply is down from 11 watts down to 9 watts. I've got the output turned on doing 0 dBm, so it's actually working and doing something. And that bridge now is barely warm. It's like 40 degrees. So I was looking at on the thermal camera here, which is going flat, so that's what I was on charge. That was about 43 degrees, I think it was, last time I looked at it, and that's been on for a while, and it's not getting hot. I can leave my finger on that, so that's fine. It seems that I was dissipating an extra 2 watts into that bridge, and this is everything plugged in, working. That should all be doing its thing. So I think I'm actually safe now. It hasn't rebooted again. It may not do it until I actually put all the covers on and gets, you know, obviously more heat around it because it's enclosed. I think that was it. A bad bridge. Pretty confident. Right, got it back together. Let's power it up again for the last time and see if it continues to behave. Output on, increase the output, increases the other way, increases usually up, 0 dBm. We'll see if it cuts out or not. You can still see it on screen. Maybe I'll get a bit closer, make it even easier for you. If it cuts out, you'll see it flicker. Power is 9.4 watts right now, which is good. That's kind of in line with what it was before when we did the previous testing. So let's leave that powered up for a little bit and see if anything goes horribly wrong with it. I don't think it will. I think we're pretty good now.
2 hours later.
So there you go, it's still working fine. I just thought I'd show you on a camera here. 20 dB max, all the way down, 10 dB at a time, down to minus 70 dBm. Which you can still just see the noise there, and I've done the 1 dB and the tenths of a dB steps as well, and they're working fine. So it looks like it's well and truly fixed now. So there you go, that's what it took to fix it. All those parts and a thermal camera. Yeah, I mean, The thermal camera was a nicety. That's what really showed up what was going on, because it's a nice quick way of finding something which is getting hot. You can also go around and do things like touching it with your fingers. Obviously when you've got mains of powered equipment, that can be troublesome. If you touch things which you shouldn't be touching because it's mains powered, you have to be careful of that. But most cases, things like capacitors and these things, they're usually okay, but not always. So if you are working anything like this, think about what you're doing. I don't want anyone getting electrocuted because I touched the wrong thing inside a piece of equipment and had a bit of a bad day. I don't want that to happen, so be careful what you're doing. This seems to be fixed now. I'm happy with that. Job done. Don't forget to subscribe over there. Other videos to watch down there, other repairs. And there's a Patreon support link over there to help you buy bits of gear like this to make videos about. Also there's a thanks button down there too. Just do a one-off thanks thing, push that, look, it's about there somewhere. You can push that, you can do a one-off donation if you choose to. Okay.